Hi, I just wanted to take a couple minutes and go over an application problem that is similar to one that you'll see on your homework. You have the application problem in front of you. Let me just read through it and then we'll walk through finding the sinusoidal function that would model the data given. So it says here, hurricanes are categorized with winds of 111 to 130 miles per hour, corresponds to a category 3 hurricane. Winds from 131 to 155 miles per hour corresponds to a category 4 hurricane. And winds in excess of 155 miles per hour corresponds to a category 5 hurricane. So the following data represents the number of major hurricanes H in a certain region, category 3, 4, or 5, each decade X from 1921 to 2010. So we're just going to answer part A of this question, which is finding the sinusoidal function in the form of y equals a sine of omega x minus phi, then plus b, that models this data. Okay, so let's look at finding our amplitude. So our amplitude is found by taking our max value. So let's look at here. The maximum number of times the number of hurricanes occurred was 41. So we have this is equal to our max value, 41, minus our minimum value. So our minimum value, looking at our data, looks like it is 24. And then we divide this by 2. So 41 minus 24 is 17, all divided by 2. So this is our A value. Of our function. So now we want to look at, the next thing that we're looking at is our vertical shift. So we can get that vertical shift by looking at our max value, which is 41, plus the minimum value, which is 24, and divide this by 2. So we have a vertical shift here of 65 halves. So this is our b value of our function. So far we have y is equal to 17 halves sine some value x plus our 65 halves. We now want to look at our period. So in here, it's a little bit off, but if we look at our max value, we have a max value of 41 to the max value here of 41. So if we look at the intervals, we have 1, 2, 3, 4, 5 intervals here. From our max value to a max value, from max to max. So that is like our period. Our period is equal to 5. Our period, though, recall, is equal to 2 pi over omega. So we know 5 is equal to 2 pi over omega. So we can want to solve for omega. We can multiply both sides by omega. We get 5 omega equals 2 pi, or omega is 2 pi over 5. So far we have y is equal to 17 halves sine of omega 2 pi fifths x plus our vertical shift of 65 halves. Now we need to look at our horizontal shift. Before we do that, if we are looking at this, we know that our period is 5. Let's split up our period into 4 different intervals. For this, if we split that up in 4 different intervals, we're looking at from 0 to 5/4. So an interval is length 5/4. Taking our period, divide that by 4. And then we're going from 5/4, adding another 5/4 to 5/4. That gives me 10/4. I'm just going to leave it and not reduce it for now. And then from 10/4, adding another 5/4 to this, we get 15/4. And then from 15/4, adding another 5/4 to 15/4, this is 20/4. So recall our sine function starts at the midway line and then it starts increasing. So for here, this interval, normally it's increasing. Then the next 2 intervals, it decreases, it hits our midline and it decreases some more. And then the last interval, we increase again up to our midway line. But if we look at this, so we would hit our max value if this was a normal sine function when x is 5/4. Is where normally our max would hit. Without any horizontal shift. So without a horizontal shift. So now let's look at where our max really occurs. So if we look at this, our max occurs, so 41 was our max. Let's look at what interval that occurs at. So this would be 1 interval, 2 intervals. Actually, so that's the 4th interval is where it's hitting. And so the 4th interval is where it hits. And so we're going to look at 4, where it would normally hit, minus the shift. So 4, which is our shift, minus the 5/4. So if we get a common denominator here, multiplying 4 is our common denominator. So multiplying 4 by 4/4, we have 16/4 minus 5/4, which is giving us 11/4. So far, what we have is this y is equal to 17/2 sine of omega, which was 2π fifths, times the quantity x. Since we're moving this to the right, we're going to put minus 11/4 in our parentheses. Outside of that argument, we're going to have plus our vertical shift of 65/2. So we're almost done. Let's just distribute our 2π fifths inside that parentheses here. So we get y is equal to 17/2 sine of 2π over 5 x minus 2π times 11. So this is 22π all over 5 times 4, which is 20, plus this 65/2. And I just want to reduce any fractions down. So we have y equals 17/2 sine of 2π over 5 times x minus 22 and 20 both have 2 in common. So 2 goes into 22 11 times. So this is 11π all over 2 goes into 20 10 times. Plus 65 halves. So we found the sinusoidal function that gives us a good estimate of mapping our data here. So hopefully that was helpful.